So, let's see here. I mean, I know how the chess pieces move, but I feel like sharing this information on this article is actually very helpful for people who are not as familiar with chess. Hmm. Okay. Yeah, see, I like this article. This is actually a very good article because it shows a visual representation of the places that the chess pieces can move. This is one of the best articles, actually. You know what? I'm gonna bookmark this page because it's actually super helpful. Because I need to be able, making a chess game is no small feat. It's something that takes a long time. But long before being able to, long before being able to have a functional chess game, we need to have something to represent the pieces. We really do. And I'm gonna look up something with the C programming. Like, okay, let's see. Um, C initialize array of strings. Let's see here. Okay, I want to see here. Okay, so okay. Okay, the example program illustrates initialization of an array of strings. Well, okay, I don't want to. Okay, I'll accept the cookie so the stupid pop-up goes away. I hate the pop-ups on websites. I really hate it. Like, it's stuff that people don't understand. Like, do you think my mom knows what cookies are and what the pop-ups mean? A lot of people don't know what this stuff means. Even I don't even really understand what it means, and I don't care. All we know is we figure out which thing to click to get the pop to go away. I'm trying to read a computer programming example here. I get frustrated by the internet when it fights with me. But I use the internet all the time to remind myself because I know how to initialize, um, you know, an array of integers. But this is an example. Okay, so constant character pointer array. Yeah, let's see here. That's one way to do it. Okay, let's see here. Or char pointer. Let's see here. Okay, yeah, you can assign the strings that way as well. Let's see here. String malloc dot 5 times size of char pointer. Let's see here. Yeah, there's different ways. Um, yeah, you can make you can initialize an array of literals. Yeah, see, there's all these different ways of doing it. There's so many different ways. But do I want to use a string or do I want to use an integer or do I want to use a set of integers? See, all these decisions, I have to make these decisions when I'm just checking on the stream here. Like, so if I want to represent the, let's see here. I've got enough information memorized that I might be able to go ahead and just start working on something. So here's what I'm thinking of doing. I'm gonna do a special challenge. I'm gonna close the current source files and I'm gonna look at something. So let's see here. So, well, first of all, yeah. So let me look for the word struct. Do I have struct in this one? No, I don't. Now, let's see. In my checkerboard, let's look for the word struct because I'm going to be making a struct. Okay, so there's a struct checkerboard, and that's declaring a struct checkerboard of main check. So main check, it's the checkerboard. But there's different ways to do things. So for example, I think I have a way I'm going to do this. So I'm actually going to take a look at Chaste Tris, because in Chaste Tris, I had, let's see here. In fact, let me check something. Yeah, 12.3 kilobytes for Chaste Tris.h in this one. Okay, and then, okay, let's see here. And then, oh, interesting. 1989. That's strange. Strange. Let's see. What is anything different here? Is anything different at all here? Not really. I mean, it would still, yeah, there's a structure for a Tetris block. And there's an array of 16 colors and stuff like that. Yeah, see this this is an example. Let me go to the original file just because I believe this is a copy of the other one. So 12.4 and 12.3. I wonder what the difference is. I honestly don't know what the difference is. Actually, I'm going to open this file and then I'm going to open the other file because I just want to know what's changed between the two different versions. I have two Tetris games. Oh, yeah, that's what changed. The height of the grid is what changed. It's pretty much the same. That's not a big deal. It's really not. Okay, but anyway, so here's the original. For Chaste Tris, I had done this. And then notice how I had used this integer array for defining the, different blocks. There had a 4x4 grid. However, here's what I'm thinking of actually doing. We're going to actually use an 8x8 grid is what we're going to use. We're going to use an 8x8 grid of I could use integers or I could use characters. Either way, the result's pretty much the same. So here's kind of what I'm thinking. I'm thinking of an idea. I have an idea in my head. Oh, actually, I think I have an idea here. See, programming is a time-consuming process. A lot of people get bored with this, but I think I have an idea. So first of all, I am going to make, first of all, I'm just going to make an array. I'm going to copy from this file, and then I'm going to actually create a new file. I'm going to create a new file. Okay, so we're gonna need to make a new file. So SDL chaste chess .h. Okay, so here's the thing. So just like I had a file here, Chaste Tris or Chaste Tetris, whatever you want to call it. Just like I had this here, and I also had a structure. I'm still going to reference this file as I make my structure because it reminds me how I did things. Let's see. I'm going to be referencing it a lot, but I'm going to be putting things into this new file. Okay, so, I'm going to, SDL chaste chess .h. Okay. All right. And I'm going to paste this here. I'm going to modify it. Okay. A file for representing what the chess pieces are and controlling their movements. Okay. The movements I'm not going to get to in this stream. That's going to take a whole another session. Okay. So here, it says int block array, but here's the thing I'm going to try. I'm going to try something. I'm going to first of all, let's do Okay, so we're gonna do, okay, in chess, uh, okay, chess board pieces. Okay, okay. And what I'm gonna do is, obviously, this is gonna need some heavy modifying. But what we need to do is we need to in the main file, we need to include this file. So include, and yes, I do use a plain black and white view text editor when doing my code because it's easy for me to read. Because sometimes syntax highlighting gets harder for me to read. I'm weird that way. Okay. And I'm gonna, okay, so now we have, okay, so yeah, so the program still works because nothing has really been changed. And just out of curiosity's sake, I'm going to see what happens. What if I include this twice? Oops. Nope, redefinition. Yeah, okay, we only need one definition. Okay. I'm going to try something. I have a little bit of an experiment that I'm going to try. So here, okay, we're going to go back here. I'm going to try making a string here. Okay, I'm just going to make it a string. Okay, cannot initialize array of int from a string literal. Okay, with array with okay, yeah, cannot initialize array of int from a string literal of type array of char. Okay, so let's change this to okay, wait. Yeah, what happens if I just do chessboard pieces? It's not going to know what that is. A chess unknown type name, chess, of course. We're going to make this a character array. See, I'm a bad programmer, but even I have made games, so. Okay, now notice it gives no error. Okay, so here's the important thing. So I'm pretty sure I have a good memory of the chessboard. Here's what we're gonna do. We're gonna, and you can do multiple strings, in fact. So for example, if I do this string and this, let's see here, it works. Okay, so here's what we're gonna do. My first string, we're going to, okay, I'm gonna do letters. Okay, should I use capital or lowercase letters? Okay, actually, I know how I'm going to decide. I'm going to open my web browser again, and we're going to look at chess notation, because I want to make sure I'm consistent. Okay, so chess notation. Okay, so let's see here. So, yeah, so K for king, Q for queen, R for rook, B for bishop, and N for knight. So, chess notation uses capital letters. Okay, yeah, when a piece makes a capture, an X is inserted immediately before the destination square. So bishop captures the piece on e5. Okay, yeah, so that's how they know if it was captured. Okay, so what I'm going to do is, yeah, so king, queen, rook, bishop, and knight. 1, 2, 3, 4, 5. Yeah, there's 5 pieces. They all have a letter. N is for knight because knight starts with K, but K is for king already. So N is for knight. Okay, so that's important. So now that we know that, let me go back here. Let's start with the top because we're going to be doing black's board on the top left. So we have, okay, I'm going to turn my caps lock on. Yeah, that's not right. Okay, so rook, knight, bishop, and then I believe it's queen, king, and then bishop, knight, rook. So there's the top row. Okay, so that's how it's going to be. So So what we're going to do, though, is we're going to have to, most of the board is going to be empty, but okay, then the next row is 1, 2, 3, 4, 5, 6, 7, 8. So 8 pawns. There's 8 pawns that black has. Okay, and then what we need to do is we need to, okay, empty space. I could also use zeros. I could use zeros, or yeah, should I use zeros or should I use dots? I don't know. I'm not sure, or should I use commas for empty space? I don't know. I'm just not sure what I should use. Let's go. Yeah, let's go with 0. Yeah, let's go with 0 because otherwise, if like, see if I'll show you if I do all blanks, it's a lot harder to read how many there are. It just doesn't look as cool. So let's go with 0 as the representation of nothing as a character. Now that's the character 0, not the actual number 0. Okay, because this is a string. So then we have 2 rows for black's pieces. P is for the pawns, by the way. Then we have 4 empty rows here. And then we're going to copy the pawns here. And then what we have to do is we have to, yeah, so then here, because that's the thing is, even though, like from whites, the queens are across from each other and the kings are across from each other. So this is the view where white is on the bottom and black, so it's all one character string. It's all one single character string. So, but what we need to do here is we need to make sure that this is right. We're going to make sure this is right. We're going to compile and rerun the program. Okay, so yeah, the program still works. Nothing is malfunctioning yet. But we need to check and make sure this data is properly loaded. So here's what I need to do. I'm going to, okay, I know what I'm going to do. Let's go, okay, let's see here. Wait a minute, that's the wrong thing. Okay, let me go back to main.c. So at the start of the program, before we've even loaded anything, to save us time, okay, so let's, before we've loaded anything whatsoever, let's try something. First of all, let me go back to this and let's see here. I'm gonna do, okay, so void, okay, I need to turn my caps lock. Okay, so void print, okay, print chess. Actually, okay, let's do chessboard print. We're going to have a function. It doesn't take any arguments. It's just a function. And here's what we're going to do. So now what we have is x and y are already included as global variables. They're already included as global variables. So here's what we're actually going to do. Okay, wait, this is the wrong file. I'm going to close that file so I don't get confused. So what we're going to do is we're going to do a little bit of a map here. So actually, wait a minute. I just realized something. I actually, that file I closed, I actually am going to need that file again because I'm going to reference a little bit of a loop here. So let's go to STL grid draw. So I have, okay, yeah, okay, these are a little bit too complicated. Okay, I'm looking for a simpler function because I'm going to be copying a quick example from, okay, let's see, Chaste Tris. Okay, so let's see here. We want to erase, yeah, let's see here. I'm trying to think here because there's a certain, yeah, oh, here it is, Tetris clear screen. Okay, that's what we're going to do. But we're not actually going to clear the screen. What we're going to do is we're going to modify this example. Okay, so here's what we're going to do is we're going to modify this, and then what we're going to do here, actually, wait a minute, I just realized, okay, first of all, I'm going to try something. I'm going to show you, first of all, I'm going to do a basic printf statement. We're going to try, I'm going to try, what happens if we just do printf, we're going to print a string. We're just going to print a string here. We're just going to totally print the string. And the string is going to be chessboard pieces. Let's try what happens. Let's see what happens if we do that. Let's just see what happens. Oh, that's right. We haven't actually called the function. We need to call the chessboard print function here. So let's call it here. Oops, I forgot my semicolon. Okay, let's try this. Oh, okay, see, it prints all the characters, but then it messes up there because they're all on the same line, and we don't want that. Also, okay, yeah. Also notice it doesn't print the new line. So let's try something. Let's go back. I'm gonna close this one now. Okay, first of all, let's make it print a new line at the end of that string. So that's nice. It prints it all as one string. That's not bad. That's actually not bad because it at least shows that all the data is there. But what we want to do, what we want to do here is we want to make it map it out. So it needs to look exactly like this. So what we're going to do now is we're going to copy some code. Okay. Actually, okay, let me go back, because see, I keep closing and opening the file because I don't want to get confused with it. Oh, but it remembers. Okay, yeah, let's go back to clear. Okay, here it is. We're going to copy this data here. We're going to copy this loop specifically. We're going to copy it here. And what we're going to do here is this. Now, see, notice if I were to try to compile and run it, it would fail miserably. Also, let me close my web browser because I don't want to keep switching back to this. So because these were defined in my Tetris game, but they're not declared here. They have no meaning in this. And we are not going to use grid width or height because we know that this is a chessboard. We know the values are 8. So what we're going to do is instead we're going to use putChar. That's what we're going to do. We're going to use putChar, the function. So we're going to do okay, so here, the chessboard, okay, we're going to printf chessboard pieces. We're going to, okay, we're going to do, okay, I have an idea. Okay, so we're going to do putChar, because putChar is a very basic function to put a single character. Actually, let's just try outputting a lowercase f. Let's try that, just for the fun of it. Oh, that's right. It's not going to work because it's messed up. Okay, so let's try putChar, and what we're going to do is we're going to do this array. This is the array, and then we're going to use the formula. This is the formula, basically. So, but instead of grid width, we're going to well, we know that it's 8. We just know that this is 8 because the width of the board is 8. So we're modifying the formula because the grid width is going to be, in this case, the chess grid is going to be 8. So what we're going to do is it's going to print that out. Okay. And then what we can do is we can do this. So let's try this. Let's see what it does now. Let's see if it works. Oh, grid width. Oh, of course, because grid width and grid height both need to be changed to 8, because they're going to be 8. We know that they're going to be 8 because the chessboard is predefined to be 8 by 8. Technically, I can make a chessboard that was more than 8, but that would be a whole weird. So now see what it does. Check this out. So first of all, okay, I'm going to do something. So see, if we do that, it'll be just like it was before because it does the same basic thing. And then here, so let's print f. Let's put, like, we're gonna put char, and we're just gonna see now how it shows the exact same string twice. It's a way of doing it, but we don't have to do it that way, because now, see, you might wonder, why did I do this fancy x and y loop? Why did I do it that way? Well, I'm going to show you why, and here's exactly why. So, we're going to, after each x loop, after each time it goes through the x loop, it goes through that row, then we're going to do the put char of new line. Okay, we're going to put that here instead. Okay, let's see here. Now it works. You see how it works? So first you see it as a, you see it as its big long string by itself, but then you see it properly represented. Okay, that's very cool. And in fact, we could even make it double space with each one if we wanted to. We could totally do that. It works. It totally works if we want. Wait a minute. What's that? Wait a minute. Does it? Oh, wait. No, that's, yeah. See, I would have to do, I'd have to do put char twice to do that. Yeah, that's crazy how that is. It's kind of unnecessary. Actually, you know what? Let's go back to using printf. Okay, let's just change this to, because printf is more modifiable, because put char works, but I'm going to go back to printf. So here's a printf statement with that, and I'm going to show you why I want to use printf. So if we do printf, so first we're going to have our format string, which is going to be a character, and then we're going to have a space between the characters. So now let's see what it looks like. Wait, segmentation fault. What did I mess up? I feel like I messed something up. Well, what did I mess up? Because it was working before. Let's see here. Wait a minute. Warning passing argument one of it makes pointer from out of cast. That's weird. Because it was working. What did I do wrong here? Oh, because for printf I need to make this a string. That's what I did wrong. This is now a string. It's not a single character. Okay. Okay, see, now it works. So now what I'm going to do is I'm going to show you, we're going to comment out this first part here. And then I'm going to show you if I were to add a space here. You see that? Now it looks more like a perfect square. Doesn't that just look more beautiful? It looks much more like a perfect square because, see, without the space, it's all too close together. It's way too close together. But yeah, okay. Actually, here's what I'm going to do. I'm also going to do a little bit I'm going to do a new line before the loop, and then another new line after, just to separate it from all the surrounding stuff. So see, there it looks weird. It just doesn't look right. So it's all smushed together. But then, and also, what happens if I just have a percent sign? What happens if I just have a, wait, just a percent sign? Oops. What happens if I just have 2% signs? Then it does only percent signs, then it's print. But yeah, I mean, I'm playing with printf now, which is not the point of this game, but so now, and we could also do the space before. That also works. That also totally works. We could do 2 spaces before. It works, but now it doesn't look right. We could do X, Y. So see, now we have complete control. But it's best to just do, yeah, I think it's, okay, let me check something out. Okay, so there we have a representation of our chessboard. It's not actually bad. In fact, though, I think I actually want to do the space beforehand. Okay, because then it looks like it's indented almost, like it's underneath the other thing, but over to the side. So now we have a text representation of our chessboard. So that's a good chessboard. You know, it's good. That now that's the default. That is the default setting of it. But that's only the initial one. We're going to have to make another board that's the actual board we play on. But that's just the initial representation. So here's what we need to do. We're going to make we're going to be making a structure, okay? Okay, so what we're gonna do, we have that, and it works, and it prints things right. But what we're gonna do is we need to have a okay. So we're gonna make a structure. So let's look at how I made my structures here. So struct Tetris block, and here's struct Tetris grid. But do I want to make a structure for do I want to make a structure for the entire board, or do I want to make a structure for the pieces themselves, or both? Actually, let's make a structure for the chess pieces themselves. Okay, yeah, I think I have an idea how I'm going to go about this. So, okay, so what we're going to do is we're going to have a structure. Now that we have all this set up, we have a structure for, yeah, we have a structure for chess piece. Struct chess piece. Okay, struct chess piece. Okay. Okay, so there's going to be 2 values. We're going to have, they're going to be character values. The C on my computer keyboard, which you can't see, looks like an O because most of it's faded. But yeah, my keyboard is just old. So char color. So there's going to be a color, which is whether it's black or white. Is it a black or white chess piece? And then char, let's see here. Should it be called ID, identifier, or will it be item or name? Char name. Okay, let's just have ID, char ID. Okay, so we have a struct for chess piece. And then let's try. Okay, because here's an idea. I'm gonna try something. I'm going to just make a. I'm just gonna. This is just gonna be a test. Just a total little bit of a test. I'm gonna get rid of that function here. I'm not gonna call it. So struct chess piece, and we're gonna name a struct. We're gonna name a chess piece dude. We're gonna have a chess piece named dude. Let's just try it just for fun. Unused variable dude. Oh, no semicolon at the end of struct or union. Okay. Okay, wait a minute. Do I have a... Huh. Oh, I need to have a... Yeah, I need to have a semicolon there in my definition. But we're going to have a struct chess piece. Okay, so now we're not using the variable dude. So let's just try using it. So, okay, so dude dot ID equals let's just name it T. Let's try that. Oh, T undeclared. See, because we need to make sure this is a character. Let's make sure it's an actual character, just for fun. Yeah. Okay. Variable. So it's set. So it dude.id is T, and dude dude dot color equals W for white. Let's just try that. So it's a white dude, basically. I'm not sure what the T stands for. Oh, and I'm going to turn off my phone because it's driving me crazy. My phone keeps clicking because it's my turn in chess in several games. I'm playing 20 games at once. I'm actually in the chess tournament on chess.com, which is funny. Because here I am trying to work on making a chess game. So here's what we need to do here. We need to have a... I think I have an idea. We're gonna have to set chess piece. Okay, so I'm thinking of something. I'm totally thinking of something. A chess piece could be either it exists as something or it's non-existent. Okay, so I have an idea. So what I'm going to do is I'm going to proceed. I'm going to comment out this section right now. Yeah, let's see. Let's just make sure it works. So, okay, the program still works the way it did before. Okay, but what I'm going to do here, we're going to have, we're going to be making another structure. So now that we have a chess piece structure, that can represent either a piece that's black or white or a certain name of a certain color, but we're going to have a... Okay, so yeah, so a struct Tetris grid is going to be like that. Okay, but I'm going to write it my own way. Okay. Okay, so what we're going to do is we're going to have a struct yeah, we're just going to call it struct chess grid. Okay. And then we're going to it's the entire chess grid, which, you know, because I had the chessboard pieces there as an array, but this is going to be I could call it chessboard, but let's just call it chess grid to be consistent with Tetris grid for my other game. So we're going to have okay, actually, let me try chess piece. Okay, yeah, chess piece thing. I'm gonna try that and see what happens. See, unknown type name, chess piece. Okay, so we have to declare it as that it's a structure. So struct chess piece, thing. Actually, I'm gonna look back at this because I just want to make sure. So yeah, int array Tetris array size. Okay. So what we're gonna actually do is we know, yeah, so okay, let me go back here. So chess piece, yeah, so chess piece array. Okay, I think I have an idea. Okay, so the chess grid is an array. The chess grid is an array. So let's just name it array. Okay, chess piece array. And it's going to be an array of 64 bytes. Actually, it's 64 elements of type chess piece. Okay. So what we're going to do here, we've defined a chess grid. Yeah, actually, you know what? I'm getting really confused. I need to go back because, see, I have a horrible memory. I have like the worst memory in the world. And so I don't remember exactly how I did things. So, for example, let's see, we had main grid appeared, yeah, main grid dot array appeared almost everywhere. Okay. Okay, so here's what we're actually going to do. I think I've got it. Main grid. Except, wait. Yeah, okay, so what we're going to do is then we're going to define struct chess grid, and we're going to name it main grid. Except, wait a minute. What did I name the other ones? I'm trying to do it consistent with how I did it here. Okay, so let's find the first occurrence of main grid. Let's go back to the very top of the file. Yeah, so there's main grid and temp grid. They both work. For right now, there's only going to be a main grid until I need to make a temp grid. But we're going to center everything around this basic assumption here. So struct chess grid, main grid. So now that we've created a main grid for our game, okay, then we need a function. Okay, void init meaning initialize main grid. Okay. So then we have this function, and what it's going to do here is that it's going to go through this loop, but instead of printing it, it's not going to print anything. Okay, so instead of printing anything, it's simply going to set okay, so here, okay, so okay, so we're gonna take this out here. So we're gonna have main grid dot array, okay, with this same exact formula, x plus y times 8. equals chessboard pieces. So let's try it and see what happens. Ooh, wait a minute. I may have made a mistake. And there's my file browser. Okay, wait. What did I mess up? I feel like I messed something up here, but I don't know what. I don't know what I messed up. Yeah, I'm trying to figure out. Wait, okay, let's see. Where's the... What am I missing? Okay, first of all, I don't know which line is line 65. Okay, so, okay, here's what I need to do. I am going to have to open up my source files in Visual Studio Code because I don't have line numbers in this text editor, and that's driving me crazy. So let's go back here and let's open up this. We're gonna open up in Visual Studio Code. We're just gonna open this up here. Okay, so let's see here. First of all, let's get rid of errors here. Wait, identifier printf is undefined. Oh, that's right, because we need to open the folder. We need to open the folder here so it knows the context of everything. Okay, so then where's the error? Too few arguments to function call. Let's see here. Where's this? Where's this at? Wait a minute. What does this mean? Yeah, I don't know why is it showing me this. Because there was nothing... Yeah, there was nothing wrong in this part. Yeah, I don't know what this error means. Okay, line 37. If window equals null. It's trying to say that too few arguments in function call. No, there's nothing wrong. I don't really know why it's giving me this error. Okay, but okay, first of all, over in this file, where is line 65? I may have made a mistake somewhere. Okay. Oh, I know what it is. I forgot to put the parentheses. Of course. Let's see here. Ooh, incompatible types when assigning to type struct chess piece from type char. Of course, because I tried to define to the array as if each element of the array was a character. But each element of the array is actually a chess piece thing here. So main grid array dot ID. So it's the identifier that is actually going to be set to the chessboard pieces there. That's how it's going to be. So now the program compiles with no error. It's really strange how that happened. So now here's what we have to do. Now we've copied the values, but how do we know that the values are copied correctly? How do we really know? Well, we're just going to make another function. That's what I do. I make lots of functions and then delete extra ones later. Okay, so what we're actually going to do now is we're going to... So the original chessboard print Now what we're going to do is we're going to, okay, so we're just going to call it the, okay, chess grid print, chess grid print, okay. And then we're going to be doing, okay, so main grid, actually, wait, let me just, it's main grid array, yeah, we're just going to copy it from here, and we're going to put it here. So now let's see here. Oh, that's right, I haven't actually called the function. Now we have the chess grid print, but we haven't actually called the function. So let's go back over to main here. Okay, let's get rid of this. I wonder why it's giving me that bizarre error. Too few arguments in function call. Still get error. Expect, wait a minute. What's this? Huh. It's bizarre. Why would it expect a why would it expect, it should not be expecting a semicolon there. There's something bugged about this because it works. Yeah, that's just weird. See, this is why a lot of the time I don't even mess with Visual Studio Code. But I'm going to ignore the errors that it's showing me right now. So let's go back here and let's do chess grid print. Now it's interesting here because now, yeah, what's going on here? Okay, I'm going to close the Visual Studio Code text editor because something's weird. Okay, so chessboard print. Okay, we'll just call it chess grid print. What we're going to do here is we're going to get rid of that and that. Okay. Oh, of course, because we haven't initialized the main grid. So notice that it does all the spaces, but it hasn't initialized the grid. So we have to copy all the data from the one grid into the other grid. Okay, I think I know how we're going to do this. So first, init main grid. Okay, so we go back to main.c. So first we init the main grid. All right. Okay, see, now it has all the data correctly there. Now it has it all correctly there. However, there's still one little bit of a problem. We haven't initialized which pieces are black, which are white, and which are nothing. We have not done that. We haven't really done that yet. So we need to have a way of doing that. So what we're going to do next is let's make a separate array. What we're going to do here is we're going to, so chessboard, we're going to copy this array and we're going to make a different one. Okay, chessboard, Okay. Chessboard pieces. Okay, so chessboard pieces. Let's see. Chessboard pieces color. Okay. Okay, that's what we'll do. Chessboard pieces color. And then what we're going to do here is it's going to be either black or white or 0. So what we're going to do here is we're going to do 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's just do this here. And then let's do the same down here. And then let's just copy this to down there. So now we have chessboard pieces color. So now we have the pieces identified as black or white from this array, but we have what their names are, or their ID from the other array. I could have renamed this to ID, but whatever. It doesn't really matter because we're going to copy all the right data. So what we're going to do here, we're going to, when we initialize the main grid, we're going to, because there's a character color and there's ID. And which order these are in doesn't really matter necessarily. So we're going to main grid array. Okay, main grid ID is that. And then the main grid ID of color is going to be just 4 pieces color. And it's going to be the same. Okay, so now it's so now we know that it's printing the same values as before, but now we want to show what the actual ownership, which pieces belong to black and which belong to white. So let's do something. So now let's do, actually I have an idea that could simplify this. I think I have an idea. Well, actually, we don't even have to do it that way necessarily. Actually, yeah, we do. I'm gonna do something here. So, what we're gonna do here, we're gonna do, okay, just like we had. Okay, yeah. Well, I'm gonna shorten the code. So we're gonna have a struct piece. So struct piece P. Okay, so what we're going to do here is there's going to be, wait, that's the wrong, wait, no, this is the right function. We're not going to be using that thing. Okay, so we're going to do here now is we're going to struct chess piece P. We're just going to name it P. And then what we're going to do is P is going to, okay, all right, here's what we're going to do. Actually, do I want to do it that way? I'm still making decisions. This is harder than I thought it was going to be. Okay, yeah, struct, yeah, okay, so here's what we're going to do is, okay, so we're going to do P equals main grid array at that element. And then, because we have copied over that element of the main grid, it's going to be pi.id. That's what we're going to do. Because that'll make it shorter. Okay. And it works. Okay. So then let's try something else. So we have p.id, but let's add another character to this. Let's try p.id, and then we'll just have p.color. Let's try this now. Hey, it works. It actually works, but notice that the piece name comes before the piece color. So it's like rook black, knight black, bishop black. Okay, so I'm going to reverse it. So what we're going to do now is we're going to move the color to be displayed before the piece. So to keep it from being so black rook, black knight, black bishop, black queen, and then 0 represents that it's not a chess piece. It's a non-existent chess piece. It all represents that it doesn't belong to either black or white. So that's an important thing to realize. So now we have a much more accurate representation of what this is going to look like. Okay, so now we have we have the representation there, and also what we can do. Let's try yeah. Let's see here. We don't technically, well, there's multiple ways of doing this. So let me try commenting out that printf statement, because that's only a test. And then let's just try printing out a single value again, just for fun. Okay, so let's try p.color. Yep, that shows what's black, what's white, what's just empty. Okay, so we have a representation now. Okay, that's good. That's actually really good. But what we're going to do now is we're going to just make it the p.id. Okay, so there is everything at the start. I mean, everything is there. So now, before the game has even loaded, we've initialized the main grid, and before we even create the window. And another thing that we can do is we could do return 0 if we wanted to just return before the program. So before the program tries to load SDL anything, there it is. So we have a representation for the pieces already. We already have a representation now. But how do we actually turn this something that displays in our window? Well, that's the thing here. Actually, also let's do something. What happens if we don't call the init main grid? Then it just has empty space. That's weird. That's very weird. See, the initializing of the main grid and printing it, it's technically not necessary to print it, but I'm going to keep printing it because that actually makes it much more fun. Okay, so I'm going to use the restroom again, and then I'm going to check the comments. See, I'm on, let's see, yeah. I'm on Linux right now, and the OBS isn't built in with Twitch support. Only the Windows version is. So I'm actually going to go. First of all, how long has my stream been going? How long has it been going? An hour and 13 minutes at this point. So let me go. I'm going to go to my web browser again. And let's go to Twitch. I'm going to go to Twitch here. I'm going to go to my profile.
Oh,
okay. Wait. I want to go to the profile that other people see. I don't even know how to navigate Twitch. I don't visit Twitch. I stream on Twitch. I don't even know how to navigate Twitch. I don't. Wait. Why is my category Words with Friends? I changed the title to. Oh my god. Yeah, I changed the title when it's still saying Words for. I changed the title. I changed the category. Did I forget to click save? I don't know what I actually did. I really don't know what I did. I don't understand how to use Twitch. I'm really bad at this. And I have no comments. So you know what? Forget the comments. I'm going to proceed with the next step of my plan. Okay. So now I want to be able to get an actual representation. Okay, so I'm going to comment out the return 0 part because we're going to continue the program. But okay. So here's the chessboard, but we need to get text onto these squares. I'm going to use text for an early draft of representing the pieces. So how do I get text in my games? Well, there's the way I did it in Chaste Tris 1989, but see, this one was complicated because I had to use the TTF library. So I had to do a whole thing where it creates a text surface, and then it converts it into a texture, and it did all this fancy stuff, but I had no control over the text. I was able to do it, of course, but the way I got text in my first 3 games, I did it my own special way. So, for example, let's go over to Chaste Tris. Let's look at this. See, this text for Chaste Tris, which is my Tetris game, all of this was done with my own predefined font. And as you see, the text works, but it's highly customized. And so I actually had functions for doing all this really amazing stuff. Now, I don't really need all of the features of what I put in this game for the text, but I needed to draw the text, and I need to be able to choose the color as well. So let's see here. See, I had in my let's see, yeah, STL chaste font texture. That's because this was the textured version. Okay. So yeah, this I had done some fancy stuff here. I had done some really fancy stuff here. But let's see here. Some of these comments are horribly outdated. I had definitely okay, so yeah, this one was interesting because this one, okay. Oh yeah. Oh yeah, this is the special one. Yeah. Yeah, see, and I didn't need anything. Yeah, see, this one was different. This one was very different because these ones, like back when I made my Tetris game, the background was black and it was assumed that the text would be white, and I didn't have any code in there to plan for different cases. I actually didn't. It just copied the characters exactly as they were. That's going to be fine for a rough draft, though. That's going to be fine. So here's what I need to do. So what I need to do here, um, I'm going to copy that from that folder to my Chaste Chess folder. So here's what we're going to do. So instead of SDL Chaste font texture, okay, because see, there are a lot of things in here, because for example, the palette, the Chaste palette, that is not actually defined here. That's defined in a whole other thing. So here's what I'm thinking of doing. I'm going to make a modified version of the font file. So what we're going to do is we're going to do SDL Chaste. Okay, so Chaste Chess font texture. And I also want to look at something else here. Because see, in my original Chaste Tris, I had, if I go here and open this, my original Chaste Tris, this is what it looked like. I didn't have the fancy thing going on there. I didn't even have the fancy thing. I could have added it, of course, but I kept it simple. And it was different because it didn't actually use textures. It was actually very weird because Chaste font, it worked. It absolutely worked, of course, but it did it differently. Everything was very different in the way that it did it. Whoa, that was a very, very complicated one. Okay, yeah, I had done some complicated stuff here. I'm going to have to do some major rewriting. This is going to be a big project, but I'm up to the challenge. So here's what we need to do. Now that we have this file here, we're going to copy this. We're going to copy that name of the file, and we're going to hashtag include the name of this file. So what we're going to do here is, oh, that's right. I need to include the .h extension. Okay, so that's what we're going to do here. So now notice that it has, okay, STL Chaste font texture. Okay, wait. Okay, so here it is. First of all, let me clear the screen. Let's try make. So first error is that Chaste palette undeclared. First using this function. It doesn't actually have a. And you know what's strange about that though, is I could have sworn that I had another project. Let me try something. I'm going to try something because I'm pretty sure I had another. I had something here. Okay, yeah, this one was a little bit different. Let's see here. Okay. Oh, interesting. It's interesting. So this one loaded the surface and then copied the pixels from the surface to this structure. And then it had, this had for saving and loading various different formats. That was weird. Man, I had done some very strange, okay, yeah. Some of this I don't need, but I'm just looking because I feel like, okay, I had done an LGBT palette. I had palettes for making different sets of colors. That's so weird though, because I had done something. Okay, so LGBT draw text. Okay, so LGBT load. Um, okay, let's see here. LGBT draw text, because this used a whole different thing. Um, huh. That's strange, because I'm trying to see how did I do the color here. Pixel equals, oh, I had used a main color. So I had used a main color variable is what I had actually done. Okay, that's what I had actually done. I had used a main text color one. That's what I had actually done. And I could do something similar. I can absolutely do something very similar, but it's going to be different. It's going to be different the way it's actually implemented. Because this has a structure called LGBT, and I'm not using this structure, but I will be using a variable called main color. So let's see here. Um, okay. Okay, so I think I have an idea. I may reference that in the future. What I'm going to do is I'm going to go back to what I was doing here. So, let's see here. So we have, okay, we need to load the font. That's right. We need to load the font. So I need to load the font in a similar way to the way I had done it, because I have all this data here. But I need to actually load the font similar to the way I had done it in Chaste Tris 2, because the font has to be loaded. So let's go after we process the command line arguments of the Tetris game. So then font 8 equals chaste font load, and then main font equals font 8. Well, that was one way of doing it. That was certainly one way of doing it. But technically, we don't even need all of that. Yeah, technically I don't need all of those. We don't even need a font 8. I even had allocated for the Pico 8 font. So if I wanted to change to the Pico 8 font, because I had set that up separately, I could have done that. Huh. Well, I'm still deciding. Okay, sure. Sure, let's just do it exactly the way it was done in the Tetris game. Okay, so yeah, because the font structure, each character had a width and a height, and there was a surface and a texture associated with that font. So, okay, so right after the game had just gotten started, or after everything was initialized with SDL, then we loaded the font. So whereas the chess grid, the data could be defined before the SDL is loaded, this one actually has to be done after SDL is officially loaded. So after it sets up the checkerboard and it does its first present, what we're going to do here is before the main loop, because now remember, okay, loop equals 1. Okay, yeah, the global variable loop equals 1, but let's make loop, okay, first loop equals 1. I'm going to show you something. I'm going to show you something cool here. So when we do make, oh, that's right, chaste palette undeclared, first using this function. Okay, first of all, I'm going to paste this here. I'm gonna paste this, but then I'm gonna comment it out, because what we have to do here in the source here is we have to get rid of the palette information here. Okay. palette. Okay, so let's find palette. Okay, because see this pixel equals yeah, okay. We're not gonna actually use that yet. We're gonna change a few things. Function of chase next color. Where's chase next color? Yeah, we're gonna delete that because we're not gonna be having a next color. Yeah, that's something entirely different. Okay. So see, it now the game behaves exactly normal, where it prints what square is being clicked on after it displays the initial setup of the chessboard. But what if in main.c, okay, yeah, that was that, yeah, so that was that one. Okay, yeah, so but yeah, that was the wrong main. Okay, so what happens if we set loop equal to 0? Notice how it loads and draws the chessboard, but then it disappears. That's because it never actually enters the loop. So loop has to be 1 or the program will not continue. Okay, so that's important to know. So here's the thing, here's what we have to do. So when I did my chess game, I had loaded things and then I had done welcome screen chaste font. So let's go to the graphics place of Chaste Tris and see. So I had done chaste font drawstring scaled, and I had chaste font drawstring special, and yeah, so I had yeah. So a lot of it was chaste font drawstring scaled. A lot of it was that. So let's try something. So what we're gonna do here is let's try okay, so okay, so here's actually what I'm gonna copy an example here. I'm just gonna copy an example because we're not doing a title screen, at least not yet anyway. So at the beginning of the loop, before it tries to check for input and draws everything that way, what we need to do is let's try something. Wait a minute. It only draws, okay, so it only draws the text when somebody clicks something. Yeah, that only then. Okay, so let me see something. Okay, so when I run the program, nothing changes. Yeah, see, because all the squares are a perfect checkerboard, and then when I start clicking, then the color changes. So only then does it actually do something. So that's actually very interesting. So let's try something. Okay, I have an idea. So what we're going to do now is before the loop begins, we're going to try something. We're going to try drawing text before it registers that. Okay, so sprintf text. We're just going to try something. It'll probably fail. Yep. Ooh, text undeclared. See, we have to actually have a character string called text is what we actually have to do. So let's find the character string named text. So text x. Okay, so here we have okay, character text and text x, the x position of where text will go. Okay, so I have an idea. So what we're going to do here, we're going to copy that because it seems silly, but I need to have a global text, and I could have built one into the chaste. I mean, I put all this other stuff in this file, so why I didn't put a global text variable within this file, I'm not entirely sure, to be honest, because it's certainly referenced. Huh. Yeah, because there's textures, but yeah, yeah, that's just weird. I don't know why. But anyway, here's what we're going to do. We're going to put this text, so it's enough for 500 total bytes. That's more than enough, I think. In fact, we're not even going to do text that big. So, and then text X, I don't know if we're going to be using text X or not. We may not even be using a variable named text X. And there's not a variable named scale. There isn't. Not yet. Let's see here. Actually, okay, here's what we're going to do. Okay, so, and then there's going to be, so there's character array name text, and then there's text scale. Yeah, scale. Okay, that's what we're going to do. Text scale equals 1. Okay, so that's what we're going to do here. We're going to try something. So let me go here, and let's try something. So I'm just going to try something bizarre. Oh yeah, so what we're gonna try calling this. Okay, first of all, let's try making. Let's put at location 0, 0. And then let's see here. Oh yeah, so wait a minute. Okay, so yeah, first the text that's gonna be is a string. So if we look at the file here, so chase font drawstring scaled, we have the character pointer S. So there's the text, then there's the X and Y location, and then the scale finally. Okay, so I got it now. Okay, this is confusing to me. And I'm the one who wrote it. So let's do at location 0 and 0, and then have, yeah, let's do text scale be the past value. Let's just try it. Oh, wait a minute. Parameter texture is invalid. Oh, render copy error. Perimeter texture is invalid. Why is it invalid? What did I do wrong? I did something wrong. Oh, I think I know why that is. Okay. Yeah. Texture. Okay, so yeah. I think I know why. So see, so it still draws the chessboard, but it the perimeter texture is invalid. That's because, okay, I think I know why. I think I figured out the problem. So what we did is, oh, of course, yeah, because we had drawn the checkerboard, but notice, oh wait a minute. First of all, I didn't actually load the font. Yeah, that's crazy. And then notice that I loaded it after. I technically loaded the font after I tried to draw text. Okay, let's try this. Ooh. Okay, I think I already know what the error is, but I'm going to walk you through what it is. So we're trying to load a font file. But that font file, because notice in here in our chess game, the font folder doesn't exist. But here it does. And here's the font file, the actual file. And I'm opening it in GIMP so that you can see. Here are all of our characters. basically, yeah, very big. So yeah, this is all of the characters. All of the characters for my font are in this bitmap image, a typical Windows bitmap image. So yeah, the font file doesn't exist. So of course the texture is invalid. Why didn't I think of that to begin with? So let's copy the font folder from Chaste Tris 2 into this folder. Oh, hey, it works. See, it's very small, but it says programming Chastity White Rose. Interesting. Now, we can make the text bigger. We can totally make the text bigger. In fact, what if we set the text scale to be 5 here? Hey, that's nice. But instead of just multiply that, let's set the text scale. So text scale equals 4. Hey, that's not bad. Let's try making it the text scale be 8. Hey, that's not bad at all. That's really not bad. Okay. So what we're gonna do here is, but that's a big string. Okay, so I'm gonna try just the string chess. We're gonna try this. So notice how when it draws the text there, it has the black background. It just draws the black background along with the rest of it. It's actually quite strange if you think about it. So that's not the way it's supposed to be, because we want the text to be drawn on top of it, but we don't necessarily want all of the background with it. So I have a way of getting around that. I have a way of doing it. So here's what we're going to do. So what we're going to do is we're going to use a different function. Because, see, I had different functions. I had, for loading the font. So I had loaded the font. Actually, let me do something. Let's just try, instead of font 8 equals chest font load, let's just do main font equals chaste font load. That's what we're going to do. We're just going to load it. There's only one font that's going to be used. Okay, so it works, but we need to fix this. We need to look at a better way of doing this. So the chaste font drawstring, it doesn't draw a scale, it just draws it at its original size. So render copy. So render copy is nice. That works. And then this one also works. But then this uses direct pixel access of the source font surface to draw only when the source pixel is not black. But this one is special because it can optionally change the color for each scaled pixel. So what this does is it uses the source surface width Okay. And then it does this bizarre formula. So it first sets up where the character will be copied from. And then it does this own direct pixel access method. This is a routine that I wrote. It's very bizarre. And I remember basically how it works. But if the pixel is non-zero, then it will draw a square to a destination. But here's the trick. The color that it draws, what the actual color is the pixel value here. But we haven't set pixel anything because we're not using the palette in this case. So what we're actually going to do is here, instead of calling this function, instead of calling it special, because special is so vague of a term. Okay. Let's see here. Okay, I'm trying to think of what to name it because it doesn't include the background. The background is transparent. Hey, I know. We're going to rename this. Okay, so I'm going to rename this alpha. We're going to rename this alpha. Okay, so here's what we're actually going to do. Now, and what we're going to do is we're going to make, well, first of all, I'm going to do something. So the way it runs right now is it does that. But let's change it. And do that again. Okay. But let me change it. We're going to change this. Because I can't think of anything better right now, we're just going to go with alpha. You know, the first letter of the Greek alphabet. Okay. Scaled. Okay. Alpha. Okay. Plus it's, okay, there it is. You see that? That's actually really cool. Let's see. But why is it white? Why is it white? That's interesting. Okay, so let's see here. So let's go back here. So let's see. Okay, so it gets the pixel value. It gets the pixel value from that. And then it tests that pixel value in the source. And so if the source pixel is not black, then it's going to start trying to draw. But the way it had worked for the rainbow text in my Tetris game is it used the Chaste palette. But instead, we're going to do something different because notice if I uncomment this line, that it's going to give us an error. So we don't even have a Chaste palette. There is no identifier by the name. So here's what we're going to do is now, okay, now this one was from the Tetris game. But what we're going to do now is we're going to close that. And we can also close this one. Yeah, this one was weird. Because that was the special one. Like the special cup that had Rainbow Road and Mario Kart. That was actually part of the original reason. There's a lot of history behind the rainbow text and how I developed it in Chaste Tris. That was very gay. So what I'm going to do now is I'm going to make another global variable. What we're going to do here is we're going to have text scale, okay, and then text color. We're going to have say, let's make this, let's make it purple, okay? That's what we're going to do. We're going to make it purple. Okay, so what we need to do is so text color. What we're going to do is we're going to copy this over here. And it's going to set the pixel variable equal to text color. So now, when I try to, you see, wait, it's not doing it right. Pixel equals text color. Did I save the document? That's strange. Let's see, did I do something wrong? Wait. Wait a minute. Of course. No wonder I'm having a problem. Okay, so I know what it is. Okay, so text color has to be an integer. Okay, so then we have an integer of text color. And there's nothing wrong with that, in fact. Yeah. In fact, actually, let me see how I did something. Because I'm pretty sure that even back in Chaste Tris, I had a main. Let's look for color. Empty color, block color index. int main color. Yeah, int main color. So I could have used main color, but it's not main color. Now main color would be used to control everything. It's text color. So it was just an int type. That's all it was. So int main color. That's what it was. So text color is what it's going to be here. So text color, hey, it works. See how it's fuchsia, magenta, or a light purple? Now it actually says chess, but it doesn't have the background. So it's kind of alpha, like the background is alpha now. So it works. And let's see, as soon as I start clicking, on things, then it disappears because it has the initial image that's only at the very beginning. And so technically that was only a test. And see, we can change the color. What we're going to do is we're going to set text color before we draw. Let's just try. So we set the text scale to that. So then let's try changing the color. Let's try changing it to green. Because there's the original global initialization. And then there's what happens if you don't, if you don't have another change. But you can change the text color at any time. And I'm going to be using that in the future, actually. Okay, so let's see here. So we know that it works. Let's make it green again, just for the fun of it. Okay, that's what we're going to do. So chess. Okay, so yeah, that works. Actually, let me see something. Yeah, okay. So yeah, undoubtedly it works. And of course we could do some heavy modifications to it. So for example, chaste chess. Okay, let's see what that looks like. And see, we can also, yeah, we can modify it. We can put it at a different location. So like, let's say 100, 100. We can totally do that if we want to. So now I can move the text and draw it at the exact position I want. It's actually really good. So how can this be used? How can this data be used for drawing what's on the chessboard? Well, so here's what we're going to do. What we're actually going to do is we know that the font works. We know that the font is loaded and everything. It totally works. So what we're going to do is we're going to comment this part out because we don't actually need this. This was only for testing purposes. And if I'm testing again, I'll use it again. But so here, so now it behaves exactly as it did when I first started the stream. So it works great. But we need to draw. So we have to have a way so that we can close this now. So we have, yeah, so we've got a representation now. But now we need to do something here. We need to, so SDL Chaste checkerboard, SDL Chaste chess, which defines the pieces, and it has a function for printing the grid. But there's nothing about SDL. This is all, yeah, except the name SDL. But what we're actually going to do is we're going to make another file. I split everything into different files. So here's what we're going to do. SDL Chaste chess graphics. Okay, so here's what we're going to do. We're going to make this file because the actual drawing of the text on the chessboard and maybe other features is we're going to have more advanced because we have stuff for drawing the checkerboard. We initialized the checkerboard that was defined in this file, and that's fine because the checkerboard by itself drawing that is so magnificent. It needs its own dedicated file here. But what we're going to do now is we're going to open our main.c, and then, okay, we're going to take this file name, copy the entire file name this time, and then we're going to include it just like we included all of the other things here. Okay. Okay, let's see here. So we're going to hashtag include this file as well. And then what we're going to do, we're going to copy that name of that file there again, and we're going to open said file, and we're going to make a comment. Okay, so here's what we have. So we had a in our STL Chase Chess, we had a main chess grid print. We had chess grid print, and it was a lovely function and all that. It was a lovely function, but we need to make a chess grid draw that actually draws what's on the chess grid. So here's what we're going to do. So we're going to copy this function, and that was actually very interesting because I can always modify that, but that function is only called once. That doesn't need to be optimized. That one doesn't anyway. So what we're going to do here, we're going to copy this entire function here, chess grid draw. Okay. So what we're actually going to do, for the purposes of this, is we're going to do something different here. Let's see here. Okay. So here's what I'm thinking. So here we have all this stuff that defines and it, the global X and Y values are used. However, I'm thinking of trying something a little bit different here. Let's try, I know what we're going to do. We're going to just include separate local variables. Because I just want to make sure, because global variables are nice, but you can always override global variables with local variables. Okay, so we have struct chess piece P, and then we're going to go through this, and I'm going to show you something. Okay, so first of all, ooh, yeah, it just gives me a warning about unused variables. That's totally fine. And what we're actually going to do is we're actually going to go here, and we're going to comment out the part here that prints the grid, because we don't want that interfering with anything. Okay, that's fine. That's totally fine. And then what we're going to do is we're going to chess grid print is going to be chess grid draw. So what we're going to do here, we want to, before we render anything, before we do the final presentation, before the loop begins, we're going to call chess grid print. Wait, except it's going to be chess grid draw. Wait a minute. Except wait a minute. This is wait a minute. Wait a minute. That was the wrong. Oh yeah, no, it's yeah, that's right, because chessboard, yeah, chessboard print, yeah, that was a separate function. Okay, so Yeah, so chess grid print. So chess grid draw. So let's change this to draw. And it's going to do text because it was copied from that function. So here's what we're actually going to be doing here. We're actually going to be cycling through something here. So we're going to be cycling through each of these things. But instead of printing things, what we're actually going to do is we're going to be doing the sprintf. Sprintf is just easy. I love doing sprintf because it's because that way you can copy a string, a number, anything that you want. We're going to sprintf. We're going to just sprintf here. Okay. We're going to sprintf. Wait, I did not mean to. Okay, I want to make sure I copy the entire thing properly here. So we have a complete sprintf statement. And then we're going to copy one character. Just one character here. And look, we're also going to comment out this. We may actually delete that stuff later. But, so we're going to sprintf a single character. And the single character is going to be the p.id. Okay, we're going to try that. And then what we're going to do is we're going to chase font draw string scaled alpha. We're going to actually do this. But this might turn out being a little bit weird. It might not look right. So let's try something. We're going to do it as it is, and we're going to use, first let's try using X and Y. And it's probably going to look, first let's try X and X just to see if it works. Oops, nope, doesn't look right at all. Does not look right at all. Okay, so, yeah, so X and Y. See, X and Y are used to cycle through the array. But we need separate X and Y values here. So here's what we're actually going to do. Square size is actually a very thing. So, okay, so first of all, where's rect size? Okay, so size. Okay, main check.rect size. Okay. Okay, I see. So main check.rect size. Okay, so main check.rect size is pretty much a standard thing. Okay, so here's what we're going to do. We're going to do something. We're going to be doing some different math here. So we're going to set, and notice how that is there. That looks weird. So in that case, originally that we copied from, x1 is with x divided by main check.rect size, and the same for y. y1 equals y divided by main check.rect size. So let's try it as it is. It's probably going to look wrong. Yeah, it does look wrong. That's not what it's supposed to look like. Okay, but now let's try multiplying them. So it's a multiple of 90. Let's try multiplying them by main check.rect size and see what it looks like. Oh, it's beginning to look a lot like Christmas. Oh, okay. You see how that is? That's actually really cool. Okay, that's good. And I want to make them a little bit bigger. Okay, yeah, actually, yeah, I'm gonna try changing the scale. Let's up the scale a little bit. Let's try this. Yeah, so when the scale is 9, that looks right. The scale is 10, and they should be about 80 pixels. Let's see here. But in total it's 90. So if it's okay, let's try something. Let's try making it 11. Interesting. Let's try 12. Oh, that's weird looking. I'm going to try just testing something. So I want to do a printf. Okay, yeah, let's see here. Okay, so I'm just going to try something. Printf, and let's just check what the value of main check.rect size actually is. I want to make sure that it's correct, but exactly what I think. Main check.rect size equals. Let's make sure there's a new line there. I want to just test that and make sure it's right. Yeah, main check.rect size. Interesting. It's interesting how that works. So then let's see here. If we try to make it 13, see, then it's too big. It's just way too big. See there, when we had his 12, which should already be, yeah, that's already. See, they're getting too big. They're moving outside their squares already, and that's not really a good thing exactly. Well, they barely fit in, just barely. But actually, we need to make sure the size is right. So let's try going back down to 11. Okay. So a scale of 11, so that's 88. So it's about 88. But actually, here's what we need to do. Okay, I think I have an idea. So let's try something. Let's try 10. Or how about let's just try 5 for the scale. Actually, here's an idea. Let's have 8 be the default value for the scale. But let's make sure that the function itself, the actual function itself that does this, yeah, I'm working on it here. Yeah. So there, okay, so then the actual function that draws this is going to set its own scale value. So the text scale that draws it is going to be right at the start. It's going to okay. Okay, so the text scale. So let's see here. And we already know that. Okay, and let's have a separate integer. So int we're just gonna call this x fix. Okay, yeah. Okay. So I'm gonna call this okay, let's call this x2. Let's just make it x2, have it be a separate thing. So okay, x2 equals, okay, so first of all, let's see here. Yeah, so the rect size is 90. Okay, so that's good. Let's comment that out. And then let's do this where okay. Okay, so we're going to do where main check x2 equals main check dot rect size. And we're going to do x2. We're going to display the value of what x2 is. We're going to be using x2. Okay, so x2 is 90. And let's try okay, so then main check direct size minus whatever the scale is. So the scale is, okay, first of all, yeah, the text scale. Yeah, so the text scale is going to be 82. So there's 82. Okay, yeah, but that's okay. So what we want to do. So what we want to do is we know that so the text scale times 8. Okay, so the text scale times 8. Wait a minute. Yeah, because that's 64. So 80 minus, or no, 90 minus 64 is 26. So what we need to do, okay, then we're going to divide the entire thing by 2. Ooh. The next two. Okay, so here's what we're going to do. We want to make sure that things happen in a certain way. So x2 equals main check dot rect size. It's going to, we want the text scale times 8, because 8 is the size of the font. Actually, wait a minute. Let me look, because we know that. Okay, let's look at care width. Main font dot care width. Okay, so dot care. Okay, main font dot care width. Okay, so in this case, main font dot care width is going to equal 8. Okay, so yeah, what we're going to do here. So instead of just 8, main font times care width, let's try this. Okay, let's see here. Okay, we want to make sure that things happen in a certain order. See, we want those characters to be multiplied, and then we want that to be subtracted from that. And now it's 13. Okay, that's good. That's totally good. So now that we have the x2 value, what we're going to do is we're going to make sure that each, and actually I'm going to try something. First of all, let's try, I'm going to try plus x2. I'm just going to try something. I'm going to see how it looks. Yeah, see now, see when I do it that way, it centers it, yeah, it centers it vertically. And when I do this plus x2, it's going to center it horizontally. So you see, x2 is actually a super useful thing. Plus x2. In fact, there's actually not really any reason the x2 needs to be defined on its own separate line necessarily. Let's just put it with the others. And then, oh yeah, then I have an error. Okay. But yeah, so once I get rid of this, okay. So now let's try this. Ah, so you see now see, oh, but notice how as soon as I click it, as soon as I click it, then it goes away. See, that's the important thing is it goes away as soon as I try to click it. So what we want to do is we want to make it stay on the screen. So how do we do that? How do we make it stay on the screen? Well, now that we have a function, that draws the chess pieces. So chess grid draw. So it's called once. Yeah, so it's called once right here before the first render present. But then as soon as somebody tries to click something, the whole thing disappears. And that's because it's not called in the main loop. So now chess grid draw is going to go here. And then every single time that somebody clicks a mouse button, then it's going to do this. It's going to redraw the entire scene. And then it will get the value. And then it does some fancy math to set up a rectangle to draw a rectangle at that spot, which is going to be a perfect square. Yeah, so main check.rect size. Okay. So let's see here. Ah, isn't that interesting? Notice how it does that? Ooh, we need to do something about this. See, now when it's clicked, it's selected, but it blocks the view of what the piece was. We need to fix that too. And the way we do that is we're simply going to go back here, and we're going to, instead of chess grid draw there, so it's gonna do that, and then so yeah, it draws the entire checkerboard, and then it is going to, yeah, so wait. Ah, I see. So then we have it, so it fills the rectangle, and then we're going to draw the chess grid right there. Oh, see, now it changes the color of the square behind it, but it doesn't mess it up. You can still see what the letter is. Oh, it works. It works. Okay, that's nice. So this has been a successful stream, see, because now let me do one more final review. So it recalculates everything. So it's going to, okay, oh, so if there's a mouse button down, then it's going to get what that math is. It's going, okay, so here's what we'll do. Let's move all of the graphics code further down to here. We're going to, after it gets what all of that is, it's going to basically, okay. Okay, so then we've moved all the graphics code there. Set render draw color is going to be equal to that. Okay, so then all the graphics code happens right after all the math. So you see now, upon launching the game, we have green letters here. And as soon as we start clicking, that square is highlighted. And it also tells me in the console what it is. Except, wait a minute. The x2 equals 13. I don't need that to print every single time. That was just for testing. So that value is still important to set, of course, but all right. It absolutely works. So now, you see, the text console tells me what the name of the square is that's clicked. And then the letters on top of the squares, they tell me what chess piece, if any, is there. 0 means there's nothing there. P is a pawn. R is a rook. N is a knight. B is a bishop. Q is a queen. And K is a king. I have all the chess pieces perfect. The chess squares and the chess pieces are perfectly represented in chaste chess. Now, I can't move the pieces yet. I can't do anything with them, but I can click squares and find out which square it is that I'm clicking, and it shows that which square I clicked by highlighting it with a different shade of gray. So in next stream, I will probably have to update this and make it look a little prettier and maybe do something different with the colors. So I'm not sure, but this has been a very successful stream, and this is the final result. My chess game is actually starting to come together. I've got the graphics, I've got the font down. I just need to do some more work, and eventually maybe I'll have something where I can actually move the pieces around a little bit. That's what I'm trying anyway. So I do hope somebody has watched this stream, because it has actually been a lot of fun, even though I got very stressed when my code wasn't working. So I'm going to exit this program, exit my terminal, and then exit all of my code.